Namaskar to all the listener. Today we are going to learn about past, present and future of the computer. Current era is the era of IT and computer technology. I can just take an example, very simple example, how computer has affected our life, influenced our life. Even you go to remote areas in your village and countryside, you take a tea in very small shop. Even shop wala also say that साहब पेटीएम से पैसे दे दो. It's a kind of It means the computer has influenced human life very, very effectively. It has become the part of our life, starting from our daily work to supercomputer and missiles. Everywhere people are using computers. What is the past? Before that, I'm talking about myself. I am Ashutosh Kumar Singh, working as a professor in Department of Computer Application in IT Kurukshetra. I have more than 20 years experience after PhD, worked in 6 universities of world, which includes UK, Malaysia, Australia. I got my PhD degree in Department of Electronics Engineering, IIT BHU. I did my postdoc from Department of Computer Science, University of Bristol, UK. From that university, many people received Nobel Prize. I have published 260 research papers. Out of 260 research papers, 165 papers are cited in ISI and Scopus Index journal and conferences. Having 18 H index, 47 I index and 1461 citation. Currently, my research collaboration is going on with University of Bristol, UK, Charles Stewart University, Sydney, Curtin University, Australia, University of Tokyo, Japan. Last year, I got JSPS scholarship, fellowship to visit Japanese universities. I received roughly around 10 research awards and supervised 6 research grants, written 10 books and 12 book chapters. Currently, 26 researchers are working under me. Out of 26 researchers, 20 are master student and 6 are PhD student. I have 10 years admin experience as a head of department and deputy dean. I have traveled more than 25 countries for academic and research assignment. So, see this diagram. This is the past of our computer. The old computer looked like this. I will come later for more detail about this computer. The current computer is something looking like this. It's a simple laptop. This model was very famous in late 90s and early 20s. The future is we are expecting people like a robot. And best example you can see, the computer scientist had generated Sophia. Sophia was a robot. Last year she was in India and she traveled many IITs, answered questions from professors and students. And Saudi Arabia offered the citizenship to Sophia, and Sophia was a robot. You can Google and get the videos of Sophia. So this type of robots we are expecting in future. Maybe after 20 years, 30 years, 40 years, you can see the robots are walking with you and you don't know that this person is a robot or a human being. That is a kind of expectation, the future the scientists are predicting. History start long ago, like this example of Abacus, 3000 before Christ. 3000 means currently it is 2020, so roughly around 5000 years ago, people were using abacus. It was based on rods to count and calculate, still widely used in Asia. So I'm confident many of you have used this abacus in your school, where school teachers teach us how to count using this tool. This one considered as a first computer before 5000 years. After this, the slide rule came. Slide rule was invented in 1630, and it was based on Napier's rules of logarithms, and it was used until 1970. So this, it's a kind of ruler. You can see this ruler. I remember I used in my undergraduate course, where we have to map it, and it was based on Napier's rule of logarithms. After this, 19th century, Jacquard loom, 1801, this computer was first stored program computer. Before that, both two tools, they were not able to store the values. This computer, which you can see like a punching machine, it was a first stored program, but it was stored manually, and still people are using today. But I'm not sure that which area, which country, which school, which university is using this. But I got the information from books and internet that still people are using. After this, the Charles Babbage machine, it was a kind of analytical engine, and between 1792 to 1871. This one was a kind of huge calculator. It's based on difference engine, and it can store numbers, calculating meals used, purchase metal cards. You can see here, it's a kind of mechanical computer, and it was used by steam, like steam engine, and it can accurate to 6 decimal places, means whatever multiplication, addition, division you are doing, it can do up to 6 decimal places. It was in 18th century. So today you can surprise that calculating 6 decimal places is not a big deal, but you see the time frame during 18th century. Even today also, for a human being, if I say that you have to divide a number and I want an answer up to 6 decimal places, you don't have to use calculator, you don't have to use computer, you have to do manually, and you have 1 second only. You may not do it. So the first time in 18th century, once the people feel, okay, machine can give the value, accurate value up to 6 decimal places, it was a kind of miracle during that time. Today, of course, it's not a big deal once you are using the latest laptop and calculators, but you should see the particular time. It was roughly around 250 years ago. This machine, like 1822, Charles Babbage difference engine, changing the gears. You can see it's a kind of mechanical here. A lot of gears you can see. So the calculation is basically 1 round you take it. So it's rounding, and sometimes they use manually, or they can use machine, this steams. And it was a mechanical computer. So sometimes the mechanical engineers, they claim that computer belongs to mechanical engineers, not electronics and electrical people. And it's a fact that the whole world saw the mechanical computer first in the 18th century, and Charles Babbage's difference engine machine is the one of the example. After that, ENIAC was the first electronic computer. And before moving to ENIAC, I want to tell you one thing. Most of the research of the world has only two major reasons. The first reason is common man started doing research because they wanted to make their life easy. They wanted to get some kind of food, easy life. Then they did research, or they did research because of war. So during war time, most of the research started, and electronic computer was one of them. During Second World War, American Army wanted some kind of trajectory tables for carrying the weapons. And for that, they gave money to two professors, Eckert and Mauchly, from University of Pennsylvania, to develop a trajectory table. The project started in 1943, finished in 1946, but it was too late and Second World War was over. So the computer came in the picture just because of Second World War, electronic computer. So it was ENIAC, which stands Electronic Numerical Integrator and Computer. It was like this, which I showed you just before 5 minutes, this figure. It's a kind of electrical wire. This is the first picture of ENIAC in 1942. And if you see the specification of this ENIAC, you're surprised. It was a decimal number, not the binary. Means today our computer is based on basically 0 and 1, but the first ENIAC was working based on decimal number 0, 1, 2, 3, 4, 5, 6, 7. And they were using 20 accumulators for 10-digit number and programmed manually by switches. Means this gentleman, you see, by taking manually one by one hand, he's taking the switches. So if you want to calculate, take out one switch out and then you put it inside. It's something like printing machines, like if you have seen old printing presses. In that time, every numbers we have to do manually. And they were using 18,000 vacuum tube. And the weight was, surprised, 30 tons. The one computer weight was 30 tons and the area 15,000 square feet. Nowadays, sometimes in 15,000 square feet, you have one department. And the power consumption is 140 kilo power consumption. And what was the result? Result was 5,000 editions per second. So let us analyze this first electronic computer. Of course, it was very huge. Of course, it was very heavy. Weight, you can see, it was 30 tons. And we have to use manually by switches. And this one was 1942, means roughly around just 65 years back. So it's not a long time. But see the result, 5,000 editions per second, which was not possible by a human being. Because adding 5,000 in 1 second, it's not an easy task. That one was the milestone outcome when the scientists excited, okay, even it's very heavy, taking more space, lot of power, but still the outcome, 5,000 editions per second. Therefore, ENIAC has a kind of history. After that, the next came UNIVAC, Universal Automatic Computer. It was first fully electronic digital computer built in US, and it was also created by University of Pennsylvania. This one was similar to ENIAC, but taking less space compared to ENIAC. The weight was almost 30 tons. It also contains 18,000 vacuum tubes, and the cost is, you can imagine, $487,000. So $487,000. If you want to convert into Indian currency, you multiply by 75. Then you can get the price of the computer in 1951. So I think if you calculate according to today's market, maybe it will be roughly around 10 crore rupees. But if you see, just after 10 years, these two diagrams, 1942, ENIAC, and 1951, roughly after 1 year, of course, after 10 years, you can see this computer looks better than earlier one. Better than earlier one. And they were using vacuum tube technology. Vacuum tube technology, they use roughly around 18,000 vacuum tubes. So let us see, glance through what is vacuum tube technology. The vacuum tube is considered as a first generation electronic computers used vacuum tubes, and it is a kind of a glass tube with circuit inside. Only thing is that there is no air inside of them. So you see here, in this what happened, there is a cathode and anode. So cathode, we have to heat the cathode emit the electrons, reach to anode, electron flow from one place to another place, then current start flowing. So this one is going to work based on heat, and that is the reason ENIAC and UNIVAC both need lot of power. See this 140 kilowatt power consumption, because you have to heat, and around 18,000 vacuum tubes you have to heat at a time to get the value, and therefore need a lot of space, lot of time. And if you have seen some old radios means it was roughly around 50s and 60s old transistors like radios. So you start the radio, you don't get the sound immediately. Maybe you can talk to your grandfather and or your father, they will tell you. The old time radio start, after that, after 1 minute, 2 minutes, depends on quality of the radio, price of the radio, then you start getting the sound. It means the first 1 or 2 minutes, the vacuum tube generates heat, current starts flowing, then after that you start getting the sound. That one was a vacuum tube technology, and it worked up to 1956. 1956. After this, the first transistor came in the picture. The first transistor, this technology was developed by in 1948, and here this you can see the first transistor picture, left hand side. In this, there is no something like heating kind of things, means not like vacuum tube, we need some heat here. You connect and current starts flowing immediately. They used silicon here and developed in 1948, and this first transistor won the Nobel Prize. It's a kind of, we call on and off switches, and the transistor was the foundation of second generation computer, which started in 1956. One interesting point with the transistor, No one has patent for the transistor. No company has patent for the transistor. And which you can see the ICs now, even your mobile phone, billions of ICs you have in your mobile phone. So in one IC, how many transistors? It's few billion transistors you have in your mobile phone, and there is no patent. No one has patent for transistor. But of course, the transistor changed whole world, and they use silicon. And Australia is the place where people buy silicon from that country. After that, the ICs, this first transistor was considered as a second generation. After that, the ICs came in the market. It was third generation computer used ICs, integrated circuit chips. Integrated circuits are transistors, resistors, and capacitors integrated together in the chip. So you can see this is the first picture of the IC. Now, one concept came which we call von Neumann machine, von Neumann Turing machine, and he brought the stored program concept. In that, there is a main memory. Main memory is going to store programs and data. Arithmetic logic unit is responsible for operating on binary data, like all arithmetic operations, addition, subtraction, division is performed in ALU. Control unit is there, and there is input and output. This one was developed in Princeton Institute of Advanced Studies, and it was completed in 1952. So it was look like this. You can see the red color, arithmetic and logic unit, where we have main memory. As I told you that main memory stored programs and data. Arithmetic logic unit is responsible for all the operations. Program control unit is going to give the control to ALU, giving the instruction, and there is another box which is input and output equipment. And very interesting fact, today our computer, supercomputer, mobile phones, all type of computers are based on von Neumann architecture. This von Neumann architecture was further modified by few people they call Harvard architecture, and that Harvard architecture was almost same. Harvard architecture also have arithmetic logic unit, program control unit, input output equipment. Only main memory they divided into two parts. One part is for data and one part is for program. Only one difference between von Neumann architecture and Harvard architecture. Therefore, still scientists feel that the von Neumann architecture is still used by all type of computers. This is a kind of example you can see, very old example, like 1942, 55, 1945, von Neumann machine. It's a simple hardware complex instruction, one processor you can see here. So example. So now once the transistor came in the market, it was very nice. It replaced the vacuum tubes. It was very small. It was cheaper, less heat dissipation, solid state devices, and it was made from silicon. Silicon, it's a semiconductor device, semiconductor metal. It's a kind of semiconductor, not metal, semiconductor. And it was invented in 1947 at Bell Labs by William and others. And this one was the first time third generation computer started. It started in 1964 to 1971. It was integrated circuit, operating system getting smaller and cheaper. After this, the first microprocessor, you can see it was developed by Intel, 4004 microprocessor, and this is 4004. This is a kind of example you can check. You see, it was supposed to be the brain of a computer, and it was working based on of G1 and 0. And this small IC, which you can see, has 2250 transistors, and it was known as microchip. After this, the next 1975, birth of the personal computer, just roughly around 45 years back. This one was the computer which we call MITS Altair. This computer has only 256 byte memory. 256 byte memory, not kilobyte, not megabyte. Means this computer, not even one picture you can store. And having 2 megahertz Intel 8080 chips, it was just a box with flashing light. The cost is 395 kit and 495 for assemble. So how it worked basically, we started from the vacuum tube. The first electronic computer ENIAC was based on vacuum tube. After that we moved to transistor, then transistor to integrated circuit, and integrated circuit to microchip. So you can see in 1981 IBM developed a computer with Intel. It was a IBM Intel Microsoft joint venture. They used 8088 microchip and 29,000 transistor here, and the speed is 4.77 megahertz. And the RAM, see, only 256K RAM. You can imagine, just it's 30 years back computer. How much RAM you have in your laptop? So that is the reason we can say the computer field is growing very fast, very fast. And it was having 1 or 2 floppy disk drive. Even the floppy disk, one small diskette, the first one was 5.5 inch, bit longer, bigger, and then the second one was a bit smaller, 3.5 inch floppy. There was no CD drive. After that, the Apple computer came in the market in 1977. This computer was very famous. You may have seen in old movies in 70s, a lot of Indian movies, they use this kind of computer. And it's Apple II, widely used in schools. It was released in 1984, Motorola, and considered as a first commercial computer with graphical user interface and pointing device, one mouse you can see here. Before that, there was no graphical user interface, means you have to do everything is like DOS version, or ENIAC was manually. So it was not very useful for common man, because everything you have to do by programming. But now even a small baby, a small boy also can use the computer, because it's a graphically you can see. This is a kind of slide where I gathered all the generation of computer. So you can see the first generation electronic computer based on vacuum tube. It was from 1946 to 1957. After that, second generation electronic computer, 1958 to 1964. Then the third generation started, and third generation was based on ICs, integrated circuit, and first small scale integration, and they used up to 100 device on a chip. Medium scale integration, up to 1971, and the number of devices was up to 100 to 3,000 devices in a single chip. The fourth generation electronic computer from 1971, and still we are currently using 3,000 to 100,000 devices on a chip. And then VLSI came in the market from 1978 to the current date, 100,000 to, now you can count this number, and ultra scale integration. It's a huge number here. So just within 30-40 years, you can see 65, and today, just roughly after 50 years, from 100 device on a chip, we reached over 1, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 10 to the power 8 devices on a chip. So 10 to the power 2 devices on a chip, we reached up to 10 to the power 8 devices on a chip. And the fifth generation computer, this is a kind of example I want to show you. The fifth generation computer was started by Japan, Ministry of International Trade and Industry, MITI. It started in 1982. So the computer, the fifth generation computer, look like this. And what they have, they can create computers using massively parallel computing and logic programming. This is the generation of computer. If I compare evolution of computer, and I have only simple, like only 2 years I'm taking. One computer in 1990, another computer is in 2004. So roughly the range is 14 years. So if you see the speed, 90 computer speed is 16 megahertz, and 2000 is 2 gigahertz. So the factor is just after 15 years, after 14 years only, the speed is 125 times faster. Storage, you can see 20 MB to 120 GB. The factor is 6,000 times. We increase the storage. Memory 1 megabyte to 1 gigabyte, which is roughly around 1,000, and the cost from 2,250 it reduced to 750, and means cost is roughly around 1/3. Even the inflation rate is increasing, but still the computer product prices are dropping down. And I'm proud to say that the price of all the items in the world is starting from the civil to mechanical, all engineering products, the prices are increasing. But the electronic product, the computer product, the prices are decreasing if you compare their speeds and all. And this slide is one of the example. Like 90s, the speed was very slow, but the cost was more than 3 times. I am ending the today presentation, and if you have any question, you can ask. I cannot see you physically, so you can type when I upload this video on YouTube. You can type the question. I will be very happy to answer. This is the first part of my slide. The second part I will discuss soon. By the time, take care. Bye bye.